The length of AB was 4, we were saying. Second question here is use the diagram or otherwise to find the length of AC. So I'm just going to go up here and remove some of this. So the length of AC I have here in pink. So it starts at 2, finishes at 7, which means the length of it is 5. Okay. Then says to use the theorem of Pythagoras. So use the theorem of Pythagoras to find the length of BC. So that was the stuff that I kind of started with there. Okay, so this is the hypotenuse, which is C. This one up here is opposite B, and this is adjacent C. Sorry, I have those letters all wrong. The opposite is A, and the adjacent is B. Just let me check I have those the right way around. Have a table book here somewhere. Yeah, so the opposite is A, correct. Okay, so A is 5 and B is 4. Okay, so theorem of Pythagoras, C squared equals A squared plus B squared. We don't know C. A is 5. B is 4. C squared equals 5 squared is 25. 4 squared is 16. 25 and 16 is 41. And then to get rid of this square, we do a square root, and that'll take it out. But if you square root one side, you have to square root the other side. So it says give your answer in the form. So there you go. They just want the square root. So the answer is the square root of 41. Don't need to type it into your calculator because that's what they're actually looking for. Okay. Write down the coordinates of the midpoint of BC. Coordinates of the midpoint of BC. Where's BC? Okay, so I think we might have to actually do this. So take them off. Okay. Right, so here's B, so that's going to be x1 and y1, and there's C, x2 and y2. So let's just write this down again. B is 2, 1, and C is 7, 5. And this is x1, y1, x2, y2, and we're looking for midpoint, so I'm going to go back over here, and there it is there. So I'm on page 18 of my table book. There is the formula for midpoint, so I'm going to take that, and we'll use it. Okay, so using that formula, it starts with a bracket, x1 plus x2 over 2, comma, y1 plus y2 over 2. So 2 and 7 is 9 over 2, and 1 and 5 is 6 over 2. So 9 over 2 is 4.5, or 4.5, and 6 over 2 is 3. 4.5, 3, where would that be? 4.5, 3, yeah, that looks about right. Has been the middle of that line. Okay, okay, so they want us to, on the coordinate diagram, draw the triangle DEF, which is the image of ABC under axial symmetry. Now, axial symmetry is a mirror image. That's what that means. So they want us to draw an image of ABC. So where's ABC? Okay, so ABC is the triangle we've been looking at. We want to do a mirror image of it. So B is one kind of up off the x-axis, so we want to go one down off the x-axis. So B is at 1, my dot is at minus 1, okay? So that's B image, right? So you normally say B dash, that's like the image of B. Now, A is at 5, so that means my A is going to be at minus 5 because it has to be an image. And C is also at 5, so I need to follow this line and go to 5, and that's where C dash is, and then try and insert straight lines here. So we join these two, and then another one, join these two, and then another one, join these two. Okay, so now it looks like this one is looking in the mirror. That's axial symmetry. Okay, and then a bit more of this type of geometry, these images. So triangle ABC is the image of which triangle under axial symmetry in the y-axis? So when it says this in the y-axis thing, that means the y-axis is the mirror. Okay, so we want to know if ABC is looking in the mirror that is the y-axis, where would it end up? Okay, so this, she's highlighter for this. This is ABC. If this is the mirror, what would it see when it looks in the mirror? It would see this one. So that's JKL. JKL. Triangle DEF is the image of the triangle what under central symmetry. Okay, so I'll show you how this works now. So DEF under central symmetry. Where's DEF? Where's DEF? Oh, wasn't DEF the one we drew? I called it A dash and all that. Yeah. So this one is DEF. Okay, so DEF under central symmetry. Okay, so essentially with central symmetry, what you have is that this is the point they're talking about, 0, 0. So what you want to do is try and get another line. You want to take a line, go through the center, and go out the far side. And just change the color there. Take another one, go through the center and go out the far side. And then one more, go green. So I should be able, oh no, didn't get a line. So I should be able to go through the center and should be on a dead straight line with K. Yeah. So that's how you do central symmetry. You go through the center. So if you go start at this one and go through the center, you end up at this one. Okay, so the answer to that again is JKL. And triangle ABC is the image of which triangle under a rotation? No. Could I rotate? No. So you have to try and think, if I were to take that and kind of rotate it that way, would it end up looking like this? Like it would if I flipped it over a few times. So let me think, if you drew flat, and if I flipped it again, the diagonal will be over there. I think any of them would work. Yeah, I think you could probably answer anything that, because if you flip any of them over, they'd end up looking like that one. So yeah, I think I'm going to go with GHI just because it hasn't been the answer to anything, but I think all 4 would be right there. Okay, nearly there. So the line L has a slope 2 and it goes through that point. Write down the equation. Let me try and get this a bit closer. Okay, so the equation, where is it there? It's this one. move that. Right, leave it there. Okay, so this is x1, this is y1, and the slope is m. Okay, the y, the plane y and the plane x stay. So it's y minus y1, which is minus 1, equals m slope, bracket, leave the plane x, minus 3. Double minus here, this thing here. So when two minuses come together, they make a plus. And here we have to multiply. So it's 2x minus 6. And then they say here that they want the answer to look like this. Okay, so essentially what they're saying is get y on its own. Alright, so we're going to keep the y where it is, and we're going to take this and move it. Okay, so that's going to be y equals 2x minus 6, and when I move a plus 1, it will become a minus 1. So y equals 2x, and you can add those two or subtract those two. So you end up with minus 7. Okay. So is the point on the line? Very simple. You sub it in to check. Okay, so this is your x, this is your y. So it's y equals minus 3x plus 5. And I'm going to take the minus 1 and put it in here. And I'm going to take the 2 and I'm going to put it in here. So we have 2 equals minus 3 times minus 1 plus 5. So 2 equals, the two minuses make a plus 3 plus 5, and then 2 equals 8. So that is obviously not true. And if it's not true, that means it's not on the line. Okay, so question here is, are these two lines, big thing is perpendicular. So if they're perpendicular, then you find the slope of one, multiply it by the slope of the second one, and you should get minus 1. Okay? How do you find the slope? So you can see it here, when you have y equals mx plus c, there's your slope. So it's right in front of the x. Okay? So here's my first line. This was the one I figured out. So what was in front of the x? A 2. So the slope of my first line is 2. I'm going to multiply that by the slope of the second line, which they gave me. So I'll just change my colour. So that's there. Minus 3. That's minus 3. When you multiply them, you get minus 6. Minus 6 is clearly not minus 1, which means they are not perpendicular. All right, last question. So the diagram shows a road sign indicating that the road ahead narrows. How many axes of symmetry does the road sign have? Just the one. Ooh. Let's try that again. Insert line. That's the only place that you could fold it, and it would fall perfectly onto itself. So the next one. The road sign is in the shape of an equilateral triangle. Write down the side of each angle. So equilateral means all sides are the same and all angles are the same. So if all angles are the same, then you have 180 degrees split perfectly in 3, which means each angle is 60. Okay, so I put a construction in. Construct an equilateral triangle with sides 7.5. Now I'm not going to be able to do this properly, so I'm going to tell you how to do it. So you start with your ruler and you simply measure out a line just with a ruler, flat line that is 7.5 centimeters. Okay, then what you're going to do is you take that ruler. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. You take your compass. So you've got the compass. This is the pin of the compass, and this here is your pencil. Yeah? And you take it up here, and you put the pin of the compass on 0, and you put the pencil on 7.5. So you open up your compass to the correct width. You then bring that compass down here, you put the pin here, and you strike an arc. Keep the compass exactly the same, put the pin here, strike an arc, and then basically all you're doing is drawing a line from this side of the line to the dot, and then drawing another line from here to the dot. And if you do it correctly and remeasure it, that should be 7.5 and that should be 7.5. Okay, so simple enough construction. And that's it. Okay, so sorry it was in two halves. I don't know what happened at the end of the first one. Anyway, go through it, make sure that you understand everything. If there's anything you don't understand, I've added you all to Teams, so we can do sort of like a live classroom thing if there's any specific questions that this video hasn't answered. Please try and stay on top of the work. Okay.